This piece of charcoal is burning, and so is this one. What would happen if the charcoal were burned in an atmosphere containing more oxygen than ordinary air? The two pieces of charcoal are each covered with glass bell jars. Oxygen is slowly let into one of the bell jars. The charcoal burns more quickly in the bell jar to which we are adding oxygen. The same chemical reaction is taking place in both jars. Carbon is combining with oxygen to make carbon dioxide. But the reaction is not taking place at the same speed. Why should increasing the amount of oxygen in the air increase the speed of the reaction? To find out, let's examine what happens when charcoal burns, using the idea of atoms and molecules. Charcoal is made up of atoms of carbon. It is burning now, and its temperature is high. Air is a mixture of oxygen molecules and nitrogen molecules. There are about 4 times as many nitrogen molecules in the air as oxygen molecules. The molecules in the air are in constant motion and often collide with the carbon atoms. When nitrogen molecules collide with the carbon atoms, they just bounce off, unchanged. But when an oxygen molecule collides with a carbon atom, which is at a high temperature, a chemical reaction occurs. The oxygen molecule and the carbon atom unite and become a carbon dioxide molecule. For a chemical reaction to take place, atoms or molecules must be colliding with each other, just as the oxygen molecules and carbon atoms are here. Perhaps by thinking about collisions between atoms or molecules, we can understand why the charcoal burns faster when the amount of oxygen is increased. First, let's consider how many oxygen and nitrogen molecules are contained in air.